Hello, this is Gary Marr from Linden Community College. This screen capture is from my CIS 150 AB Summer Internet Online class. Now, this is basically Assignment 8 with the adjustments made for Assignment 9, which essentially meets try-catch processing. Now, try-catch processing is got two purposes. The first purpose is to resolve runtime errors, things like divide by zero. It's like using a subscript that doesn't exist in an array. Trying to do math on a letter instead of a number. These are fairly common type things that can happen in the course of running a program. This is more or less the garden variety try-catch processing. Probably not what I asked in the lesson though. What I asked in the lesson was more or less custom runtime errors or custom errors, exceptions to be thrown by the program. So what I thought I would do is take my assignment 8 and add the additional logic into it to show you how you would do try-catch processing in pseudocode. Now I'll give you the warning and the caveat in the beginning. Programming languages treat this a little bit differently, and it's not exactly like I'm showing here, but I can at least explain the concept here. Much of it's the same, but not all of it. Different languages do it different ways. So inside this program, pretty much everything stays the same as it was. And if you noticed before that when I had an error in my input, I returned something called error. I didn't really explain much about it then. I'm going to talk about it now. Error, the way I'm going to use it in this particular pseudocode, is a runtime error, an exception my program has raised because it doesn't like what it sees. If I use try-catch processing, I can take that information and have my program continue normally without abending. Usually if a runtime error is encountered, the program dies. You get something on the screen, a red circle with a white X or cross. If it's Windows, Apple's something different that says, okay, you blew it, lose face, you made a mistake, this isn't going to run any farther. But if you use try-catch processing, you can get at least some sort of information back to the user so they can try again in some cases, or in other cases know that they just need to restart the program. So what I've done for each one of the inputs, and again this is kind of a simplified example, there's more complicated ones out in Canvas files I believe, and also in probably the readings, but what I've done here is for each one of the inputs, after I ask for the cost information in this case, and after I put it to the screen, I have a try verb. Inside the try verb, it's going to be looking at all the lines that follow it for exceptions, runtime exceptions. And what I can do is have one or more catch blocks, each one identifying a specific runtime error. Since the runtime error I'm throwing it is called error, that's one of my options. And then I have another statement here, just simply catch by itself. This, for all intents and purposes, is what I would call a wildcard. And basically a wildcard says is that, well, I'm kind of expecting to get error as a runtime exception, but if anything else happens, do this. So what I'm saying there is if anything else happens, just print the words unexpected error on the screen, and hopefully my user will know he has to start the program over again. So for each one of the inputs, I've done this, and I'll show you them all in a second, and that's for my custom exception. However, if for some reason we can't execute pseudocode, so I can't really show you this, if I was going to do a calculation and I asked for cost, and somebody mistakenly put in a letter, okay, well, that does not compute. I probably would have got a data type exception thrown by the programming language saying that this does not compute. And providing I know what the exception is, I can catch it and continue processing. Maybe ask for the number again. Now, how this is done, it depends on the programming language. Since this is pseudocode, I can't really show you this. There are some Python examples. I know some of you have used Python and are learning it. You might want to look at some of those. But this exception handling is very important in terms of making robust code. Okay, programs that aren't going to break. So if I go down a little farther here, you're going to see I have a block for the price and also for serial number, model, and color. Nothing else changes. All I've done here is I simply said in each one of these sets, not the gets, because that's not anything I'm adding, I'm going to return an error if something is incorrect. That's essentially try-catch processing. This essentially is the answer for number 9 with my original number 8 program. Please, if you use it, you better add comments or it's going to come back to you. If you have any questions, let me know.